Hello everybody, we are Team 2 and this is our robot STG. We base this robot on a rover that can be commonly seen on Mars or on a robot that do harsh terrain. We want it to be a rover because it can easily do harsh obstacles and then overcome them with ease.
For mechanical design, our robot have 4 main features. For the suspension system, the suspension spring will be attached to the DC gear motor support. Also, for connection rods will be attached on both the top and the bottom of the base to decrease impact force when it moves through the ditch and lace. For a custom wheel, we designed a very large wheel with a diameter of 15 cm. The wheel was made of PLA filament and the tire was made of TPU 95A to let the robot move smoothly. On the wheel, we designed these horizontal tire grips to climb the stairs better. To grab the object easily, this rack and gate system will help us in this part. 13 cm of 2 left and right tracks will be connected with 2 gears to move the long rod up and down. In the center, there is one servo motor to rotate this short arm to grab the object. Lastly, there are 2 camera holders in this robot. The lie detection camera will be very high with 67 degrees swooping downward to lead the direction of the observer and detect the backlight. And for the QR code camera, it will be lower on the long rod to scan the QR code. For the locomotion mechanism, we use all 4 wheels in this robot, which are simple and effective. Then why don't we use legs? Because it is slow and needs to consider many conditions to make the robot stable. Also because on the field, we had the different heights of terrain. The suspension spring system is very important.
Next up, we have our control detection system. This is our QR code detection system. We detect the QR code with the front camera and then send the message to the Pi and then light up the light bulb. Next up is our traffic light system. We detect the traffic light using AI and then send the data to another Pi. Here we have our object collection system. We collect the object by rotating the little arms here, and then we can use the rack to move up and down to pick up the object and then transport them using our robot control. Lastly, for our door opening system, we use our long arm on the top to rotate to the door hinge and then move the robot to open the door. All of this is made possible by using an external application on our laptop to remotely control the power. We can read and write input and output using the same internet network only, and this made us can control the power very easily. Lastly, our problem we faced during the development of our robot. Firstly, we changed our gripper arm from the gripper itself to a hook instead. We also increased the size of the wheel several times, from 19 to our current 150 mm size. We also broke the robot several times. We have to hot glue it, reprint some of the parts, and sometimes the robot might turn off because we were trying to brute force some of the action.